All right. So my name is Mohammed Naimuddin. I'm one of the ICU pulmonary physicians in Burien, Washington, which is just south of Seattle. And this is going to be a quick look at the first COVID-19 vaccine trial that was presented in the New England Journal of Medicine. I have no disclosures, and the contents of this review don't reflect the viewpoint or opinions of my employer. My words are my own, including any errors that I make. So the way that we're going to go through this study is by using the JAMA User Guide to Medical Literature. It's from 1994. It's an oldie but a goodie. And it's what we use, or what I use, whenever I'm trying to figure out whether a study is worth reading or not. Okay. And basically, we're going to be going through all of these talking points. And if we get all the way to the end without finding any big harms or faults, then we know that this is a reasonable study, and we'll go from there. Okay, so question number one, were people randomized to treatment groups? Yes. So in the methods part of this paper, they do state very clearly that they use a web-based system where they randomize people to either the vaccine group or the placebo group in a 1-to-1 ratio, okay? So yes, people were randomized. Now, were all people who entered the trial accounted for? Most studies will have a figure 1, like this one right here, which give you a flow diagram of what, how many people they started with all the way at the beginning, meaning how many people they've enrolled overall, and then how many of those people underwent randomization. And this will break down why people were kicked out of randomization. So some people didn't meet the eligibility criteria, some people withdrew, so on and so forth. And then after all that, you get down to they randomized the people, and so 18,860 people, which is a lot, received the vaccine itself, and then 18,846 people received a dose of placebo. This is actually a pretty similar number. So we know that the randomization, the 1-to-1, worked fairly well. And then they also tell you how many of those people didn't receive a second dose. Remember, both the placebo and the vaccine both received a second dose 21 days later. And then they clearly tell you towards the end here how many people received the second dose, and then of those, how many were discontinued. And then the final number from this is what's there. So they did account for everybody that was that entered the trial. Now, was follow-up complete? This is the tricky part over here. So it's complete to a 2-month mark for everybody. Some people have higher number of reporting because they were enrolled earlier, I think up to 14 weeks. And some people have just a 2-month mark. They do plan on following everybody to 2 years. So this isn't complete follow-up, but the reason that they gave for reporting now is that they did not think that they would be able to enroll any more people into the placebo arm because of how the effectiveness of the vaccine. Were patients analyzed in the groups to which they were randomized? Basically, this means, did anybody from one group cross over into the other group? Meaning, if you started in the placebo group, did somebody break protocol and tell you that you were in the placebo group and then cross you over? And that didn't happen here. So everybody was analyzed in the groups that they were randomized to. So far we're knocking all the items on our checklist, okay? And basically you wanna do this because you wanna show that at least the bare bones, the backbone of the study is valid. So yes, people were randomized. Yes, follow-up was complete to an extent. And people were analyzed to the groups to which they were randomized. If people aren't analyzed in the groups that they were randomized to, it adds a lot of error. And in this study, at least, that didn't happen. Or sorry, it has the potential to add a lot of error. People get switch groups all the time in different studies, but we're not going to cover that here. Now, next part, were patients, healthcare workers, and study personnel blinded to the treatment? Yes, they also very clearly say that once you were randomized, you were just given a number, and then you were given the either the vaccine or placebo based on that number. So patients, the participants didn't know what they were getting, and the staff at the sites that were giving them said injections didn't know. They were both getting similar looking glass vials. One was filled with vaccine, one was filled with saline. So overall, people were blinded. Were groups similar at the start of the trial? yes. So most trials, if they follow standard labeling, table 1 will be your demographic table like this one. And your goal when you look at this is to see if the randomization was truly random, then there shouldn't be too much deviation between the groups. So in the placebo and the vaccine group, the number of males, the percentage of males should be relatively similar. So this is 51.1% male to 50.1% male. It's pretty good. Female along the same way. And if you look at the total breakdown over here, it's 50.6% male, 49.4% females. And then they also do the same thing for breaking down people by different ethnicities. And it was fairly split between the placebo group and the vaccine group. So I will say that the groups were fairly similar. That's why table 1 is super useful. You can usually just go to any trial, and if you're feeling iffy about it, if you look at table 1 and things are really off, then you just stop right there. And you don't really read that paper anymore because you know it's not really helpful. But in this study, yes, table 1 was helpful. So we know that the groups were similar. Aside from the experimental intervention, were the groups treated equally? And so this is where in some trials, you'll see that patients who are randomized into the treatment arm will get more feedback, or they'll get more questions or something like that. And you don't want that to happen, because if it is truly blinded, you want everybody to have the same kind of treatment overall. And in this study, everybody was treated equally. So for the first month, everybody in both groups were asked periodically about the safety endpoint. So the researchers were reaching out to everybody. They didn't know whether they were randomized into the placebo group or the vaccine groups. And they asked them periodically about the safety endpoint. So did you get diagnosed with COVID? Were you having fevers, chills, local site reactions? Did you have severe symptoms, hospitalized, blah, blah, blah. And then from the second and from the first month, because the vaccine was given or the placebo, it was given at day 0, and then 21 days later, and then you were followed. So that first month includes both shots. So you're getting the first shot, and then 21 days later, and because a month is 30 or 31 days, you're in that first month where they're asking people for symptoms and adverse reactions, and they're equally asking them. This includes everybody getting both shots. And then for the 2nd through 6 months, participants had to self-report. So basically, they had to enter logs into like an online journal, whether they had any symptoms or whatnot. And compliance did fall off after the 2nd dose, but still not too bad. Usually compliance falls off a lot faster than this. So all in all, we're still doing pretty good, and people were treated equally. What were the results? So when we look at the results themselves, the questions we want to ask is, how large was this treatment effect and how precise was it, okay? And when you're talking about how large was the treatment effect, you have to ask 3 questions, which is, what outcomes were measured? Because obviously you want to know what they measured. Was the primary outcome clearly specified? Because you want to have primary outcome that is clearly stated. You don't want a study to be wishy-washy saying, you know, we kind of want this to happen, but we'd be okay if this happens. That's not good. That's a bad study, okay? And then what were the results of each outcome? And so now we're getting into the meat of this, okay? So what outcomes were measured? So remember, the name of this trial is the safety and efficacy of blah, blah, blah vaccine. So they had 2 outcomes. The first was a safety outcome, and the primary outcome was, were there any specific local or systemic adverse effects noted within 7 days of getting either dose? So either the first dose or the 7th dose, or the 2nd dose of the vaccine or the placebo. And did any other patients use antipyretic fever medications, you know, like ibuprofen, Tylenol, things like that? These were the ones that were actively solicited, meaning the researchers were calling them or asking them, and they were getting the information directly. And then the second primary outcome, were there any adverse effects reported within 1 month of the 2nd dose? Okay, so these weren't solicited. Patients could just report them in their journal. And then the third outcome for safety was, were there any serious adverse events up to 6 months after the 2nd dose? So these were not solicited. Once again, the paper includes 14 weeks of this data for some patients and at least 2 weeks of data for all patients. What were the results? So that being said, so local side effects. So out of the 43,448 total people that were enrolled, 8,183 of them had local site reactions. So this includes both groups, so both the placebo and the vaccine group, and includes both the initial and 21-day follow-up shots. So if you had a reaction at either one of those, then you were counted as a person. Mild to moderate pain was by far the most common, and less than 1% of all participants reported severe pain. Pain was less frequently reported in patients over 55 years of age, so 71% after the first dose and 6% after the second dose in people who are older than 55 reported it, as opposed to 83% after the first dose and 78%. There's a joke here about young people being more complainy, but I'm not going to get into that. But at the very least, that's what they found here. 5%, so this includes both age groups, 5% had redness after dose 1, and 6 to 7% had redness after dose 2. And then in either group, 6 to 7% had swelling after either dose, so either age group. And this is the graphs that show that. And so in these, red is grade 4. So you got pain at injection site over here, redness, swelling. And you can see that pain was by far the most common finder over here, okay? And for the swelling, there was only a few people that had enough swelling that was severe enough where they had to stop them from getting even the second shot. I think it was like 1 or 2 patients. What were the results? Okay, systemic adverse effects. So the adverse effects were once again more often reported by younger vaccine recipients, so people less than 55 years old, and more often after dose 2 rather than dose 1. So fatigue and headache were by far the most common. And so 59% and 52% so fatigue, 59% of patients reported fatigue and 52% reported headache after the second dose in patients who were under 55. And then slightly less than that, 51% for fatigue and 39% for headache after the second dose in patients over 55. And you know, oddly enough, placebo patients also had reports of fatigue and headache. So maybe it's just the injection itself and not necessarily what's in the injection that contributes to part of it, okay? Fever was reported in 16% of people under 55 and 11% in people over 5. And then and this is after the second dose. So most of these things happen after the second dose, and then very few people reported fever after the first dose. Younger patients were also more likely to use fever medications as well, okay? But that being said, 10 to 14% of placebo patients also use anti-fever meds too. So, you know, take that for what you will. Fevers and chills, if they did present, occurred within 1 to 2 days, and they resolved pretty quickly afterwards. Okay, and this is the same type of graph that's breaking down how many people got fevers and chills. This is figure 2B. I highly recommend all of you guys to look at the paper itself so you can take a look at the figures and then maybe come back and go through this presentation with the paper in front of you. Okay, and then this is 2B extending for people greater than 55. Okay, severe adverse effects. So 64 vaccine recipients, which is 0.3% of the study group, developed lymphadenopathy, and actually 6 placebo patients as well. So lymphadenopathy is your lymph nodes enlarging. Most of these resolved without any complications within a few weeks. 1 patient in the vaccine group had severe injury from the injection site itself. 1 patient in the vaccine group had right axillary lymphadenopathy, so just swelling in the lymph nodes in your armpit area. And then 1 patient had paroxysmal VTAC, which is a very dangerous irregular heartbeat. But remember, that's 1 patient out of 18,000 and so on of the people who got the vaccine itself. And then once again, 1 patient had right leg paresthesia, meaning they couldn't feel some sensations in their right leg. And so these were 4 isolated cases of these type. 2 people in the vaccine group died that was determined not to be vaccine related. So 1 was from arteriosclerosis, which is calcifications of the arteries, and 1 died from cardiac arrest. 4 people in the placebo group also died, once again, non-injection related. 2, they don't know what they died from. One person died of a massive heart attack and another person died from a hemorrhagic stroke. So 2 people in the vaccine group died, 4 people in the placebo group died. Remember, this is about 40,000 people that were tracked over months. And so you're going to have some deaths. And at the very least, it doesn't look like these were related to the vaccine, but I guess we can't say for sure. What outcomes were measured? Now we're going to the efficacy side of it. So efficacy, the primary outcome, this is what you guys are all here for. It was very clearly stated what the primary endpoint was. So the primary endpoint, there were 2 of them. One was efficacy of the vaccine against confirmed COVID-19 infection at least 7 days after the second shot. So these are people that had no signs, no symptoms, no antibodies that were positive, nothing at all, starting from 7 days after the second shot was given. There was also a second primary endpoint, which included patients that, once again, starting from 7 days out, but these people also included patients that had some kind of symptoms, but not a diagnosis. So let's say you lost your sense of taste or something like that, but then you were still getting vaccinated, and then you never tested positive after that. So they wanted to know whether that was helpful as well, okay? And then a secondary endpoint was what was the efficacy against severe COVID-19? So let's say you get COVID-19 despite taking the vaccine. Did you have a really bad outcome? And how was the vaccine protective in that regard? We tend to see that in patients who get the flu vaccine and then subsequently, like a month or 2 later, get the flu. Those people tend to have a milder response to the flu itself, and so they wanted to see whether that was the same case here. So the primary endpoints, efficacy against getting COVID. So 36,523 patients had no evidence of any kind of infection with COVID during this study, and were included in the full study. Of those patients that received both shots, 162 out of 18,325 placebo patients developed COVID-19, while only 8 out of the 18,198 vaccine patients developed COVID-19, okay? The way we calculate efficacy is basically it's the proportion of patients in the placebo group that got the effect minus the proportion of the vaccine group divided by the proportion of the placebo group, okay? And once you do those numbers, this ends up being a 95.027% efficacy. The second part was, what if you had some mild symptoms and then were you still protected? And I don't know if this is a big delineating factor because people can have mild symptoms and have anything else. You could have just had the sniffles, but they didn't want to include those people specifically, so they added them in a separate case. But this is inclusive of everybody here. So out of all the participants, these are people including anybody who had any kind of symptom whatsoever. So when you count those people in, now you get 169 out of 20,000-ish placebo patients developed COVID-19, while 9 out of 20,000-ish vaccine patients developed COVID-19. Remember, this is 162 versus 169 and 8 versus 9. But if we take those numbers, the efficacy then becomes 94.619%. Not much worse than the 95% efficacy here, still really good. The other secondary endpoint was the efficacy against preventing severe COVID-19. So this is if you have the vaccine and you get COVID-19, are you protected against getting severe COVID-19? So long story short, in the vaccine group, only 1 person out of 21,314 people got severe COVID, whereas 9 people in the placebo group got severe COVID. And the 1 person in the vaccine group, that was after they fully got the vaccine, so 7 days out. This is when they should have been fully protected, as opposed to 4 people in the placebo group got severe COVID at some point before getting the second dose. 1 person got it in the week after the second dose, and then 4 people got it. And so the efficacy of protecting you from severe COVID, even if you get COVID, if you get the vaccine, is 88.9%. Moving on, how precise was the estimate of the treatment effect? So that's where you're getting into p-values and confidence intervals and stuff like that. And basically, you want to be fairly confident that this is not the result of random chance. Like you're not, if you flipped a coin 18,325 times, is it going to be, is somebody going to have COVID, just by random chance? And that's where confidence intervals and things like that pop in. And this was actually pretty good. It's pretty precise overall. So their overall confidence interval was 90 to 97.9%, and that's the vaccine efficacy fell right in between. So I'd say it's a relatively precise estimate. Now, the data I've just presented to you thus far, if you believe it, and I think there's a pretty good reason they should, based on the fact that it hasn't really checked off anything bad on our checklist yet. Now we get into, can we actually use it to help our patients or help ourselves? So will the data help me? And the thing that is really important to always consider is that a lot of the studies that we look at, the patient populations aren't really applicable to us at all. So these are studies that are coming out of Europe, or maybe even in the United States, where the patients are all white male, age 50 to 60 or something like that. Well, if you live in a metropolitan area in the United States, you're probably not treating only white male patients, So you always want to make sure that the demographics that are studied in the study itself fit your patient demographics. And if they do, then you can be a little bit more confident that this applies to your patient population. And if we look at it, the study is actually pretty well broken down between men and women, which is nice. You never want a study which is, super heavy on the men or super heavy on the female, because you don't know if it's going to work on the other gender. Or, the study doesn't go into transgender or people who don't identify. But just looking at people who binary identify themselves, at the very least, the study is fairly equal in that regard. It is also relatively good at the percentage of the patients that were included that were non-white, so people who were Hispanic, people who were Black. There was a sizable representation, maybe not as much as we would like to see, because in my practice, I have far more Hispanic and African American patients than this study included. But honestly, looking at the patient demographics in a lot of other studies, I'm actually pretty okay with how this came out. And the vast majority of patients in this study were from the United States. And so that also helps us because we treat in the United States. So that's good to know. If you're watching this and you're somewhere else in the world, something else for you to look for. Going on, will the results help me in caring for my patients? Were all clinically important outcomes considered? Probably. They were pretty thorough in what they were looking for. And if you look at all the graphs, and once again, I highly suggest you look at the paper yourself, they did include a fair amount of things to consider. But just like with everything, we won't know everything until a few years from now. And I'm sure we'll find answers to questions that we didn't know we needed to ask. So I'll say probably all clinically important outcomes were considered. And then, are the likely treatment benefits worth the potential harms and costs? And remember, that's up to interpretation based on how you do it. But this is a all caps yes for me. I do think so. And this is why. So this is the money right here. This is figure 3, which shows the efficacy as plotted by time. The black dots here are the patients that develop severe COVID. Notice there's 1 here in the placebo group, in the vaccine group. So in the placebo group, days after dose 1, you're seeing the same kind of rate of increase that we've been seeing for the past 9 months or so. But in the placebo group, after days after dose 1, so remember, the 21-day mark over here is where people got the second dose. And so most of the infections were even in the vaccine group, were spread out very early on. And then you got some more infections later on in the course. But all in all, and they also break it down really nicely over here at the bottom, where they tell you about the COVID-19 occurrence. And so what is the percent of vaccine efficacy after dose 1? So after the first dose, it was 82%, and then in between it was 52, but then finally after you get the second dose and you're 7 days out, you're at 94.8%. So this is the money right here. This is just showing you that at the very least, this vaccine is doing something, because if it wasn't, you'd start seeing a lot more cases up here. And this may be what we're all looking for. So to summarize everything, this study showed that this is a 94.6% efficacy in preventing infection. Some questions, we don't know how strict the participants were about social distancing, wearing masks, having hand hygiene. My suspicion is that they were probably pretty self-selective for wearing masks and hand hygiene and things like that. So take that for what it's worth. The study did not include children under 16. It did not include pregnant women. No studies ever really include pregnant women. And this also didn't include any immunocompromised people. So I think the recommendation right now is if you're immunocompromised, don't know if this is going to help you, don't know if it's going to hurt you, because that population wasn't studied at all. Same thing for pregnant women, same thing for people under 16. The study did include HIV positive patients. Um, the uh, the study did include HIV positive patients, and it did have similar results with them too, okay? The patient population is compatible with ours and thus applicable, and the study is going to keep going, and so they're going to keep following patients out to 2 years out. Current data is only available for all patients at the 2-month mark, but some patients it went a little bit longer. And on a whole, adverse effects were rare and largely mild. With all of that being said, I'm probably going to advocate for taking the vaccine, at least for myself and people who ask for my opinion. I'm not going to advocate any of you guys to do the same. I'd rather you come to the decision on your own. This also isn't a look at whether, I know a lot of people have concerns about mRNA vaccines in general, and was this rushed? I also don't think so in that regard. Once again, I'm not an expert on those, but mRNA vaccine tech has been around for a little while. We just really had not had a chance to really use it well because we never really had an event like this before. So just, take that for what it's worth. And last but not least, this was a pharma-funded study. And on a whole, you want a study that's independently done, but we're in kind of weird circumstances where we're depending on pharmaceutical companies to kind of rise to the occasion. But I am sure that in the coming years and in the coming months, we're going to get more data coming out from different vaccines, or maybe even this one from non-pharma companies, from universities and research labs. So if you're really hesitant and you want to wait until those kind of studies come out, power to you. Thanks for listening. Go Rutgers. This is me at a Rutgers football game last year with a few of my friends. You kind of think that they're socially distancing, but no, like Rutgers isn't a good football team, so nobody really shows up. But it's still fun, and I would love to get back to a day where I can go to a game again, even if it is to watch a team that is perennially losing. Thank you, guys.